All right, without further ado, we're going to jump right into the next session, and that is this is a play on like words here. I am going down the rabbit hole. Which I believe Val is going to tell us more about that. Val is joining us as a consulting engineer at Rapid7, who's going to talk more about this particular topic. Let's bring Val on right now. Hello, good sir. How are you?
Hey, how's it going?
Going good, going good. Welcome to the stream. Are you enjoying things so far?
Oh yeah, it's been real exciting. This past presentation has been awesome.
Excellent. So tell us, everybody, a little bit about yourself before we get deep into things.
Yeah, actually, I have that on the next slide if you don't mind.
Perfect. Look at that. You came prepared. Well done, sir.
Well, cool. Yeah. So my name is Val Komarov. I'm a consulting software engineer at Rapid7, formerly DivvyCloud. You gotta represent a little bit. Got my DivvyCloud hat on. I specialize in IAM security and kind of like have been for a little while, kind of helping people out in terms of what they do and in terms of securing their cloud environments. And I'm currently in charge of building out Rapid7's IAM offering. Yeah, that's a little bit about me.
Excellent. That's great to hear. And I love the title. Like, I have a great appreciation. If somebody has to come up with titles for talks at times too, I appreciate the creativity there. Well done. And I'm going to get out of the way though. I'm going to let you take over. But if you want, I'll be monitoring the chat room for questions, and I might pop in if that's okay with you to, let you know of questions that might come up. Sound good?
For sure. Yeah, that sounds good. I'm sharing the one screen, so it might be a little bit of a delay, but yeah, that sounds great. I'll just jump into it.
Yeah, no worries.
Yeah, guys. So I want to take some time, at least for the next 30 minutes here, to take you guys on a little journey down the rabbit hole, a journey that myself and a couple of the other engineers on the team with me have taken, and some of the interesting idiosyncrasies that you might find about AWS's IAM offering. So let's kind of like start out with a brief IAM overview for those of you that aren't necessarily familiar with it or don't necessarily use AWS as a cloud provider. So what is IAM? Just kind of talking about it from a documentation perspective. It's AWS's permissions and RBAC solution. Under the hood, at the end of the day, it uses JSON documents as policies to grant or deny permissions. And ultimately what that means is IAM allows you to control who is authenticated, aka who is signed in, and authorized, who has the permissions to particularly use resources. And so what do policies look like? This is the main kind of entry point behind how you go out and do IAM configuration, is through these kinds of structured JSON documents. Under the hood, this is what a basic policy might look like. This one basically goes out and says, all right, I can list the IAM action for the US East 1 target region. So it basically allows somebody to perform these particular sets of actions that are located inside the US East 1 region. So it gets a little bit crazier. The rabbit hole kind of gets a little bit deeper in the sense that you can see here, there's a much bigger policy. It does a whole bunch more things. This is something that's actually taken out of the AWS docs. You can see that there's multiple statements that exist. You can have multiple statements, multiple resource blocks, conditionals, actions, and so on and so forth. And all of this basically makes up one policy, and there are many of which that you can actually use in order to interact with IAM and configure what your users or cloud users have actual access to, or roles for that matter. And this is, one example. We've seen some really, really gnarly ones as far as some of our customers are concerned, especially things within SCPs. Now, what you just saw is an example of a singular IAM policy, and there's a whole bunch of different policy types that actually exist. Here, I've kind of listed them in order of frequency. So starting out, the ones that most people are going to be familiar with in terms of AWS are identity-based policies. Those are the ones that are basically used to grant actual permissions to our customers. The second most frequently used are resource-based policies, which kind of do a very similar thing to identity-based policies in the sense that they will also grant permissions, but that's just done on the resource side, meaning like, for example, if you have an S3 bucket, it might grant access to various entities. Permission boundaries actually work in a slightly different way, which is where it starts getting a little bit more complicated, is that they only enforce the maximum set of permissions that are allowed to be granted to a particular thing that they're associated with. Then there's organizational SCPs for doing things at the account level, Access control lists are used less frequently. And finally, session-based policies, which are very similar to permissions boundaries, but are scoped to just a particular session. So this is another really, really fun graphic that represents the full policy evaluation logic that AWS ends up calculating every single time in order to process whether you, at the end of the day, are allowed to do a particular action or deny, or you're not allowed to do a particular action. So it's effectively a rules evaluation engine where you take in a whole bunch of input representing both the policies and the action that you're trying to do, as well as some contextual variables for where you're trying to do things at, like what region and so on and so forth. And then you get a binary result as an outcome. Basically, you start out with a deny, and then if something lets you do things, it becomes an allow. Now you'll see that there's a little bit of complexity here that kind of gets introduced in the sense that resource-based policies are also a little bit special in the sense that there's some special handling logic that takes place between them, especially with regards to cross-account access and things like that. So in summary, from an evaluation perspective, IAM is a multi-step process. Most people that start out using AWS, they will look at it and they're like, okay, cool, it's just identity policies. But it turns out it's not. There's a whole bunch of different steps that you have to go through to be able to fully evaluate whether or not something can perform some action against possibly something else. It involves many different policy types. We saw 6, and I think AWS at some point is going to be introducing more. There's a lot of complex interaction logic, specifically surrounding like identity and resource policies, and SCPs is another really great example where you might have an identity policy and a resource policy in different accounts and across different regions. Things start to get a little bit complicated. And the other thing that's kind of interesting about this is kind of like the widespread nature of IAM in the sense that pretty much any time that you do anything within AWS, whether you're retrieving information or trying to update the state of something or launching new EC2 instances via an API call that was initiated by Boto3 or other AWS SDKs, or if you're even just clicking around through the AWS console, or if you have an automated system that does it, every single time that you perform a particular action, it goes through this flow in order to determine whether or not you're actually allowed to do something or not. So, all right, let's take a step back. I'm just a simple user. All I want to do is figure out what my permissions are, okay? Like, that's all I want to do. I want to figure out what I'm allowed to do. So I do some Googling, and I Google up, okay, I know I'm just going to use the AWS policy simulator. That seems like the thing that I want to do. And well, we just discovered the first rabbit hole is the policy simulator. The policy simulator actually is a bit of a trap. It doesn't support all the things that you'd kind of expect it to, and sometimes it misleads you in terms of sometimes over-reporting and under-reporting the actual effective access that you might have for whatever you're actually trying to simulate, or the set of policies that you're trying to simulate. Some notable examples of this are it doesn't actually evaluate partial SCPs, so you have to deal with either the whole org hierarchy or not. Cross-account resources are just flat out not supported. So a really good example of this is S3 buckets. If you're going to go through and you say, okay, cool, I've got account A and I'm trying to reach an S3 bucket in account B, you can put that into the resources block, but AWS isn't going to be able to pull in the information associated with that piece. It also doesn't show wholeheartedly your whole list of affected resources for the selected actions. So let's say you have the permission to update tag policies. It won't actually show you the resources that you're allowed to update in terms of the tags. So if you're trying to discover things that you inadvertently have access to, or things that a user that you're trying to control the permission set of and trying to lock down, you can't actually see the set of resources that that user is able to perform that particular action against. The good news is, though, AWS has been making really great strides, and this policy simulator has gotten a lot better, and I kind of expect it to continue to improve over time. So as long as you're cognizant about the potential drawbacks of it, it's a pretty decent tool to use in terms of simulating policies. Now, Let's go down a little bit further down the rabbit hole. Okay, so I'm now figuring out my policy and I'm trying to create a new policy in order to do a particular action or allow a particular piece of infrastructure to do the thing that it needs to do. And the first thing I want to ask is my IAM policy valid? Okay. So I just want to validate my policy, and this is the policy that I'm trying to validate. I've got, if you look at it on the right side, we've got a version tag here, a statement. The SID says allow unknown action. Oh, okay. The effect says allow, and the action says IAM : this action does not exist. That sounds suspicious. That action just doesn't exist. Okay. So let's think about it. What does it do? Well, turns out at the end of the day, pretty much nothing. If the action doesn't exist and you're trying to allow it, nothing happens, right? AWS does not allow you to do an action that doesn't exist. Well, let's think about it. If I try to use the Boto 3, which is the Python SDK, and call the create policy version in order to create a policy with a particular version, you'll have no problem doing that. AWS will let you go in and create this policy that has an action that does not exist, that does nothing. Okay, next. I'm going to try to do the same thing with the AWS policy editor, which is if you go through the console and you click on edit policy, this is you can basically edit this policy as a JSON blob. And this is actually the correct behavior, is that it goes through and actually rejects it because it's an unknown action and it won't do anything. And so therefore this policy is technically invalid. Next, if I do this in the access analyzer, it also does the same thing. It does the right thing. It rejects it due to unknown action. Now, if I tried to do it in Policy Simulator and add a new policy, it again allows it. So at the end of the day, it's a little bit inconsistent. If you're trying to go through and validate a policy or make sure that all policies that exist within your AWS cloud accounts are valid, it's not really a straightforward task. It's inconsistent. So what do we do about it? Well, the first thing and probably the easiest thing to do is go ahead and actually validate all of your policies programmatically. The Access Analyzer has added the validate policy functionality, which will allow you to go through, take as an input a policy document, provide some information about it, specifically like the policy type, or whether it's like a resource-based policy or identity-based policy, and what the context of that policy is. And it'll kind of give you back some findings that will tell you like, hey, this is invalid. So if you were to pass the policy that we had back on this screen into it, it'll actually tell you that, hey, look, this IAM, this action does not exist part will actually be an invalid policy for your environment. And then that's how you can go through and enforce that everything that you have as a policy-wise is actually valid. The second one too is if you're manually authoring something, like for the purposes of testing, you might want to vet the policy contents by using the actual policy editor in the console. It'll typically try to catch some things, but don't do like the first example does. If you're going to programmatically try to create something, don't use something like Boto 3. It won't go through the validation steps. It'll just let you do it. All right. Well, cool. So next thing, let's talk about a little bit about ARN matching. So what is ARN matching? ARN, first of all, stands for Amazon Resource Name. I actually had to Google this before. I'd always refer to Amazon ARNs, but never knew what it stood for. And ultimately, an ARN is a unique identifier for an AWS cloud resource. So here's an example of one. If you're not familiar with it, this is basically saying that this is an IAM user by the name of John Doe that exists within a particular AWS account. So an ARN pattern is a string that contains the asterisk and the question mark characters that may match one or more concrete ARNs. So the asterisk characters will basically match 0 or more characters. So if you don't have anything, okay, it'll match that. Or if you have anything past that, it's like a wildcard, it'll match that. Question mark will match a single character. It's kind of like in regex, the period operator. It'll pretty much match a single character in a small spot. So here are some example ARN patterns to kind of get an idea of what it looks like. A star will match everything. Something that looks like this, that starts with AWS IAM, the account ID, user / something will match all users in the account that was specified, with the account being 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2. And so these ARN patterns can actually be found in a couple of different places. The first one is inside the resource block of a policy element to basically say, hey, for a particular policy, it allows you to scope the actions that you're able to perform to specific sets of resources. Then the opposite way, which is on the resource side, the principal block of a policy element will either specify which principals or actors can actually perform the specified actions on the resource, this given resource. And a couple of other things are, for example, conditional keys using ARN-like. So there'll be certain things that will give you ARNs that are not directly related to the previous two, that you can actually invoke the ARN matching logic through the conditional block as well. So this is pretty important. So if you're looking to evaluate a policy to understand what their accuracy is, and you're trying to understand what the scoping of those resources are, which is a fundamental part of security, of basically being able to get the policy that does the least amount, that grants the least amount of access to allow somebody to do something, this is what you'd actually use it for, right? This would be a pretty common strategy, is you go in and you say, great, I have a user, and so on and so forth, and I would want to specify it or narrow it down to just the set of users that I expect to be able to perform a particular action. So what does an example of something like that look like? Here's a pretty simple policy. It basically allows a particular resource to assume a role. In this pattern, it says, allows assuming a role that starts with the my role in any AWS accounts. And there's two kinds of examples for what matches and what doesn't match. So you'll have something like 0123 4567 8910 role my role foo. That matches because my role dash star matches my role foo. However, my other role will not be matched because it doesn't exist with the star operator. Okay, cool. That's interesting, but it gets a little bit more complicated than that. AWS has a very specific rule set about where those characters can exist. So specifically, the wildcard character is the one that causes things to be a little bit weird. So in the first example, if you do something like this as a pattern, pretty much anywhere that you can find a pattern, and you're trying to evaluate it against something like our John Doe user in the past, AWS is actually going to come back to you and say, hey, look, this is actually not a valid pattern. And the reason why is because you can't actually specify wildcards in a resource type of a ARN. So an example of this is, if you can see this part right here that we're trying to wildcard match, it says user / John Doe. And that is not a valid place for a wildcard to exist. And therefore, something like this will get rejected. Another second one that's just kind of like worth a broad call out is, you'll see a lot of times, and if you've used IAM within the context of S3 buckets, you'll have seen this inside the IAM policies for things dealing with S3 buckets all the time, and matching against things like this, where you have an ARN of the bucket and then a path or a prefix in AWS terms to a particular file or blob within that bucket. Now, the outcome for this is actually kind of dependent. If you look at it, the way that IAM works for S3 buckets is actually kind of unique to S3 buckets entirely. So a lot of times when you're doing kind of like the processing for ARN matching, and with regards to that stuff, S3 buckets are kind of like their own special snowflake, their own kind of red-headed stepchild. Now, here's a bonus round for everybody. Let's talk about this in an interesting way. Is the following string a pattern or a concrete ARN based on everything that we've talked about in the past? What we look here is presumably a log group that's called my logs, and it exists within this particular AWS accounts within the US East 1 region. So is this a pattern that I might find in a resource block, or is it a concrete ARN that is the actual ARN of a log group called my logs? Well, answer is it's a concrete ARN. I wouldn't have guessed that the first time that I actually looked at this either. But if you actually go into your AWS console, go find a log group inside the CloudWatch service, you will find that the actual ARNs for log groups actually do have stars at the end of the log group name. Why does that exist? Well, I don't really have a really great explanation besides someone decided to put asterisks in the actual ARN. And you, as the poor developer that has to support IAM, has to now support these asterisks in ARNs, and therefore you can't ever disambiguate what is an actual pattern or concrete ARN unless you do some additional work. Here's an example of an actual log group that we find for, in this case, an AWS Lambda function. Okay, so cool, that's fine. We understand that it's complex, but that's fine. Let's go ahead and implement it anyway. Well, I go ahead and, as a studious developer, go and take a look and see what exists. I don't want to be reinventing the wheel. I'll go try to find some existing stuff to do the thing that I wanted to do. So I observed that the Python's FN match functionality does exactly what we want. With the asterisk and the question mark characters, it's perfect. It matches it exactly. It works the way kind of like shell grabbing does, with certain differences. But in general, it works the way that it wants. But it turns out that we're actually wrong. Wildcard operators don't always cross separator characters, which in AWS ARNs for resource blocks, you'll find as colon and slash being used as separator characters to denote whether something is a resource type or a sub-resource type versus something that's a user-specified variable. And so if you were to cross past those boundaries in your evaluation logic, you would actually be differing from the way that IAM handles that logic itself. So an example of this is something like REST APIs. So you'll see that this is a REST API that has some sort of ID. REST APIs is a constant value, so you can't really have stars in there. This is an actual user-specified value or generated value. And then you have the multiple stages of that particular piece that are basically sub-resources. It turns out that you'll find out if you run this for many, many different customers and many, many different times over in a high scale, that it's actually not performant. So if people do really, really interesting things in their resource blocks, which they have done in production many times, is things like this, where you might actually have a regex that basically has regex backtracking issues. So under the hood, FN match will just basically converts the stars and question marks in the Python standard library down to a regex, compile it, and try to evaluate it against the input that you provide. So if you provide an input that looks something like this, where you have A star, A star, A star many times over, you will have an interesting regex performance issue on your hands that you'll have to solve in production. And again, if you're interested in looking at this stuff, there's a link there. It's a fascinating read. Well, okay, fine. So yeah, it's pretty complex and we know that we can't do it fully. Well, so now we need to understand exactly how we deal with some of these things that are actually fixed values versus variable values. So at the end of the day, things are inconsistent. We probably need to parse those ARNs to understand their structure better. So we can match them correctly and evaluate these ARN patterns in the exact same way that AWS does. So in order to do that, we need to have some sort of a database. Now is the next rabbit hole. So let's talk about ARN parsing. So now parsing ARNs. We know that an ARN needs to be parsed into a pattern so that we can properly match them to actual ARNs in the exact same way that AWS IAM does. Wildcards in the below patterns are actually parsed very differently. We already know that. So under the hood, when we look at this, this is actually something that came directly from the AWS service authorization reference. And in here, you'll actually see things like constant values, like component slash. That's where a wildcard, putting a wildcard in that spot is actually invalid. However, putting things in like component name or component version is valid. And then you'll also have different things, like you'll actually have another example of stars in actual concrete ARNs that exist here for other services too. So AWS in the service authorization reference, which there's a link here, is basically where it publishes all of this information, right? Is it shows you what the different ARN patterns are for the different resources for each service that exists within AWS. Cool. This is great. Love it. We have all this stuff. Now we can parse our ARNs, right? No, except it's actually not complete. What you'll find is as you go along, not everything that exists in production, aka there are API calls that are made that are valid to be made against AWS that are not actually documented inside the service authorization reference nor the API reference and their corresponding privileges. Okay. Next, it turns out that AWS doesn't actually publish the above information in a machine readable format. You just get the HTML that's located in their website. Sad face. So, okay, now you have to parse some HTML. And it turns out that on top of that, there's actually some gotchas that you have to deal with in terms of using this data. And we'll talk about some of those coming up. However, not all is bad. It turns out that open source comes to our rescue a little bit. I want to give a special shout out to two specific projects. First one being Policy Sentry, the second one being permissions.cloud, in that, amongst other things, they do a lot of the legwork of publishing the service authorization reference contents as JSON that is consumable in a machine readable way. And they're really good about updating that stuff. Additionally, for anybody that's curious, there is some sample but incomplete parsing logic for the above ARNs in case you're interested on how one would actually match an ARN to a particular preference or to a particular pattern. And finally, shout out to my boss, James Martin, who did a lot of legwork, and he has a lot more interesting content to say about AWS ARNs and the oddities associated therein with this blog post that you can go and check out on our website. Now, okay, cool. Let's keep going down the rabbit hole. We've had that stuff, you know. Let's just keep going. Let's just keep going. So, okay, now API actions versus IAM actions. Now, the difference between API actions and IAM actions is an API action is actually an API call that is made to AWS. So think back to when we had the example with the policy. If I go in and I call boto3 clients.create policy version, what that's going to do is typically invoke an API call that is very similar named to the underlying function because most of the AWS SDK stuff is auto-generated. So they have a pretty good match in terms of the API call. Now, an IAM action is a little bit different in that it is a privilege that is granted or revoked by a policy, and that is something that you will actually find inside the actions block of many different IAM policies. Turns out that API actions and IAM actions are not actually the same thing. This is a pretty common assumption to make as well when you're first working with IAM and API calls. You think about it and you're like, okay, cool. Well, I'm a developer, so I'm going to go in and I want to make the API call to like create a policy action or create a new policy version, right? Well, okay, cool. Well, in order to be able to do that, I now need to make sure that I have the privileges in order to do so. And okay, well, they're named the same thing, right? So I just kind of like put one in there and it works and right, like that's how you'd expect it to be, right? Nope, turns out that that's not the case. For a lot of times, you'd be wrong. You're by default, the policies are not validated, and those actions might not exist, and you're going to spend a lot of time trying to figure that out if you don't know that. Turns out that actually goes even deeper. The IAM API actions versus IAM actions are not even one-to-one. There's not even a one-to-one relationship between IAM API actions and IAM actions. So here's some interesting examples. Here are all kind of examples of things that you'll find in the wild today. It might change in the future, but for now, it is accurate at the time of consumption, if you will. So for IAM, you might have something called ES, which some might understand stands for Elasticsearch as the service. However, for the API calls associated with that, theirs is a little bit different. For the API stuff, they call it OpenSearch. In fact, for the APIs, they have both ES and OpenSearch, both in a similar scope and context. So, I mean, there's some historical data that if you Google differences between Elasticsearch and OpenSearch, you'd kind of like understand why there's a difference in naming. However, this exists for many other services as well. As you can see, this is just one example of IAM and API service names being different. Next, we can talk about different action names. So again, kind of like what we talked about with the create policy version. Let's say I have a permission called IAM budgets : modified budget. So intuitively, when I read that, I see, okay, cool, I'm trying to modify a particular budget for a particular piece, even not knowing what the service is all about. Now, I would expect that the API call would probably have a very, very similar action name, but yep, nope, it's not. It's something different. So yeah, you'll have something that's budgets, modify budget versus create budget.
Excellent. Hey, Val, sorry to interrupt here, but really quick and not to put more pressure on you, but we're hitting up on time with this one. So I just wanted to give you a heads up on that. If we could start wrapping that up, or if there's a place that people can go to get the link to more information on this, we can drop that in the chat and make sure that they can, see the full results of everything going on here. But you were not kidding about the rabbit hole here. And so I'm quite blown away by all that and some of the complexities that are involved here with this, but you've done a great job of explaining it for someone like myself that's not as familiar. So I appreciate that very much.
For sure. Yeah. Let me quick skip down to the bottom here. There's one of many rapid services. There's a whole bunch that goes on here, resource-based policies and so on and so forth. And so now let me just quickly get to the obligatory pitch. As you know, the rabbit hole does go deeper. IAM is really complicated based on what we've been talking about here. The good news is within Rapid7, we actually do handle all the above cases because that is rabbit holes that we've kind of gone down and came back up through. Effective access, accurate policy simulation, what if scenario testing. Come talk to me if you want to find out more details. And if you ever want to look at the documentation for the things that we've done, here we have it on the DB Cloud website.
Excellent. Excellent. Thank you so much. And where can people find you? Maybe on Twitter that they can hit you up and talk more?
Yeah, LinkedIn. Yeah, I guess maybe I should have included my email in this. I'll maybe
No worries.
give it to you, drop it in the chat or something like that.
Sounds good. Sounds good. Thank you so much, Val. And I got to give you extra props too, because there's some folks that I know from the developer streaming community that look some of the questions you were asking that you stumped them on that too. So well done there.
That's awesome. Glad to hear it. Thank you so much.
Lots of good feedback in the chat for you there too. So be sure to check that out.
Cool. Thank you.
Thank you so much, Val. Have a good one.